Okay. Um, when we look at regular matter, like the atoms that make up the universe, their mass doesn't seem to be relatable to just whatever we can see. We already know that the basic protons, electrons, neutrons, all of this stuff that we have, it doesn't have mass simply based on the objects that we have on the visible spectrum that we can notice. So what is the mass of a proton, a neutron, an electron really made of? And that's the field that it interacts with. And it makes me wonder why you're looking for dark matter when the so-called, it's like you already know that the visible stuff that we already have isn't the basis of the mass of the stuff that we're already made of on the basic small scale. So why, when you go out and look into the universe, are you looking for dark matter? Well, that's because even if we think that the mass that makes up regular matter isn't made out of stuff that we can see, we can still attribute the amount of mass that everything that we can see has. We assume that it is just everything that we see. So when it comes to dark matter, what's the real argument here? Like, we know that the volume and size and weight of a kilogram of a stuff, and we can expect it to have a certain density and a certain amount of mass. So if it's all easily predictable, model based, we know how much is out there of the regular stuff that we can see. I think the main thing that people get stuck on is, how do galaxies hold themselves together? Well, the answer is that if you consider the mass of the black hole in the center of the galaxy and the mass of the stars, you'll notice that it's not just the silly idea of it warping the space-time around it, but it's also, there is energy that is around. Like when we go out to beyond the solar system, like the Voyager probe did, you end up noticing that there's interstellar winds, and it's actually only very empty in our local area of space in comparison to the solar winds, the stellar winds. Because basically our sun is blowing out all of the other tiny particulates. Because, like, really, what would be holding them? Nothing. So the tiny stuff gets blown out. You gotta wonder then, if it's not, if we know that about our solar system, that it's like from the outside perspective, it looks like a bubble that surrounds the very outer edges of the sun's influence. Okay, so somehow we're expecting dark matter, which is essentially matter. It's real physical stuff that only apparently affects gravity, doesn't affect regular matter, so it's intangible, but it has like a tug to it. And also there's more of that than there is the stuff in the universe itself. So if you have, like, imagine how big and massive and stuff that the sun is. You have to have another sun worth of mass in the solar system to account for all the dark matter that is throughout the solar system, and it's not compressed into a star. It works with gravity though. But it's intangible, it's everywhere, it's not combining to make stars. It just somehow also works with gravity. You're talking about science fiction here. Your theories of the theories that I hear of dark matter are so ridiculous the more you actually look at the universe and how it functions, that it's just dumb at this point to think of dark matter as physical matter. So then what is it? What is the solution for this energy or this stuff that's holding galaxies together so they can spin at crazy rates or whatever? The answer is the EM field. Basically everywhere, energy is all over the place. It's not just something that is emitted by a electron or a, is the photons that we like. Some ridiculous scientists I heard said that electrons basically are just flowing a bunch of photons to and from their atoms. Okay, sure. And what is an electromagnet doing? Electromagnet is surging the energies that are in an object and having it so that it's so energetic that it flows out in a circular format that wants to pull back towards the electromagnet. It doesn't just push away, it flows. What do photons normally do when you emit them from a light source or whatever? They just go in whatever direction. What do electromagnet fields do? Circular. Always. Not the same object. At all. If anything, it stands to more reason that there is another thing in there, not photons, that is making electromagnetic happen. What is it? Well, some people suggested that there's another layer of mass and stuff. It's thinner, it's smaller. They called it the ether, basically. And it's everywhere, right? But we have supposedly disproven the ether, but we've proven that there must be dark matter. You can't have it both ways. Some hidden weird object that's manipulating stuff around it, or substance. that is manipulating everything, and yet you're going to say it can't be ether, but it is in fact something of a different name with the exact same properties. I'm sorry, you don't understand physics, but you don't. And that's the problem. You're a mainstream or a popular scientist community, and you're echo chambering so hard you don't understand. Google debunkers, get on it, because seriously, you can't think of dark matter when you have this area that's literally blown out by the sun. If it's blown out by the sun, right, you gotta realize stuff is also being pushed out due to gravity. Otherwise, gravity, if it, listen, you're either being pulled in, or you're being pushed out, or you're just everywhere and being moved by things. It's interesting to know that the solar flares are a magnetic phenomenon that are so massive, so crazily powerful, that they can even reach Earth. Like a regular plasma ball or a regular magnet and its electromagnetic field can only go so far. But like, okay, that's the incorrect statements. The plasma that is ejected by the solar flare is able to go and be shot out towards us, and we end up with hot plasma from the sun all the time. So, not great, but really you have to think of it as think about it as on the very smallest scales, beyond electrons, beyond photons, the very smallest, there is this other substance. It is what causes the electromagnetic field in the first place. It's the thing that the electron is flowing through itself to connect to the atom, main structure. It's the thing that is excited when you have an electromagnet. Right? And there's a reason it is a flow and not just a push out. I mean, it could easily just be a push out. You push out hard enough, far enough away, there's a chance that it will not just come back. That's what happens when you have something as powerful as a pulsar. Its electromagnetic beam is just flowing out there constantly, and it only pushes out. There's no flow back because it pushes so far and fast, it doesn't have the ability to flow back. It escape velocities is how powerful it is. So, I mean, it can't all flow back. There's a lot of it that flows out. The thing is, you can't just think about all the stuff in the universe as being physical matter. It's not that there's a bunch of electrons out there. There's the electromagnetic field. They are two different things. The field in and of itself and like gravitational waves, what are they actually held by? They're held by an actual substance. You don't just say, oh, we're going to crash two planets together or two black holes together and they're going to make a pulse that's going to travel on nothing. It's not just traveling on the light being emitted or whatever, it's traveling on the electromagnetic spectrum. The field itself is wobbling. But that also brings to mind how, like, it's the same kind of thing as to why when you separate two quarks in a crazy amount of energy, those individual quarks now become a second for each of them. So now you started with 2, now you have 4. Because the stuff inside, the stuff that they are made of, is the same kind of, not exactly string theory, it is similar. There is geometry to an electron, there's geometry to a photon. And it's interesting that quantum entanglement has to do with the actual shape of, like, you're literally shining the light towards the calcium atom that splits it exactly in a certain way. And of course you get one particle facing the one way and one particle facing the other way. And that's because those particles have intrinsic parts that are due to the fact that it divided into this direction and it divided into that direction. Just like if you were to cut a tennis ball in half, the chirality of it, if you have one facing one way and it turns this way, and the other one is facing the other way and is turning this way, I really haven't changed how I'm rotating my hand. It's still, you know, counterclockwise, clockwise, whatever. I'm doing the same thing, right? So the thing is, people want to have this weird antimatter, or this no, dark matter and dark energy for some reason. That's like, one is the reason why the universe is spreading, and the other is the reason why the galaxies stay together so well. Well, I can also explain to you what the dark energy is. Out there in space, unless like literally anywhere in the universe, and people always talk about it, an object in motion will stay in motion unless affected by another thing. So when you're out in space, there's nothing to stop you from moving. And at some point, if you've been moving as long as everything else has been moving in space, you're really not going to stop. So the galaxies are floating away at their regular pace from the original inertia that they always had. And they're just going. But then there's also the Great Attractor, that's another issue. But it's like, You have to understand there's no dark energy. It's just moving because it's moving. It's not going to need any other thing to stop it. So unless we have something like the Great Attractor, which is another force where everything is pulling towards that. And it's pulling towards that because there's this giant current already designed, because objects already started flowing in that direction. So it could just be that we happen to be in a gigantic vortex. The eddy current of the whole thing is flowing us all towards that thing. But of course, as the flow of one set of things starts moving everything else around it, those objects also start pulling towards the flow. It's really like a reverse lightning bolt, which is an interesting phenomenon. But that's how it is. And so the thing about dark matter is that it's not a physical matter. It's not a substance we're going to find. It's already here. It's everywhere. It's the electromagnetic field. So when you really understand it, you know that there is stuff and it is affected by all sorts of things. It does move in certain ways, and they say that they've ruled out the electromagnetic field. No, they haven't. Like, they didn't even think about... At some point, people realized there are comets out there that are spouting out electric energy. Guess why? Well, it's because of interactions with solar winds and stuff. Yeah, also. But as they move through space, they're interacting with the electromagnetic field and generating that energy. It's just that the solar winds bust it off. Make it interact, make it spark out. Anyway. So we think we're going to find dark matter eventually, make it something that we can use as a energy source or whatever else. It doesn't work that way. We already have it. We already understand it. It's like just the regular mass of, like I say, the regular mass of particles themselves isn't in the physical stuff we see, but in the field around us. We're just, for some reason, not applying that to the entire universe. Right? But we think we can account for all the stuff that we can see, and it should have a certain amount of mass. What is all this extra stuff? Well, all the extra tugging force is the fields that are being pulled around, or the field, the area of the field that's being pulled around. Whatever.